Hello everyone and welcome to the ultimate and practical course on building a full stack application with React and Spring Boot. My name is Bhushan and I will be your instructor for this exciting journey. I have been working in the Java ecosystem since the beginning of my career and I have experience in building the highly scalable and robust applications that help organizations to solve the real world problems. Why am I creating this course? Imagine crafting world-class applications that solve real-world problems. With this course, you will learn not just the tech, but the industry best practices that top companies follows. There is a lot packed into this course, so let's see what's included. We will start with the basics of TypeScript, React, and Spring Boot fundamentals to set the solid foundation. Then we will start building the real-world expense manager application from the ground up. You will experience the entire development lifecycle from understanding the requirements to deploying it to production. We will begin this project by setting up the development environment. We will create the React application and the Spring Boot application. Then we will connect our application to the MySQL database. We will display the expenses and we will perform the CRUD operations like saving the expense details, updating the expense details, and reading the expense details, and we can also delete the expense details. Next we will move on authenticating the user and we will include the register and login functionality. So far I have included more than 10 to 12 features inside this application. I will be adding more features in the next few weeks. How this course is different from other courses? The entire course focuses on the real world problems. We will learn how to tackle the challenges that comes up on your day-to-day development. We focus on the real world challenges. We also provide the step-by-step guidance. Every feature is broken down into manageable steps, so we will build the application step by step. The course is constantly updated with new features and trends. We are not going to stop the development after a certain point of time. We keep on adding new features and we keep on improving the application tech stack. Also, I have included challenges and quizzes after each and every section, so you can complete the assignments and you can test your skills by answering the questions. I am so excited to share my knowledge and help you level up your career. Whether you are a freelancer or aiming for a top software engineering role, this course is for your launchpad. Are you excited to learn all these things? Come and join this exciting journey. Let's learn together and grow together professionally. I will see you inside the class. In this video, I will walk you through the demo of the Expense Manager application. First of all, the application still is in development stage, but I would like to walk you through the application. I would like to show the features that I have included so far in this course. Let's begin. Currently, our application is not deployed into any of the production server. It is running on the local system. Our React application is running on the port 5173, localhost 5173, and Spring Boot application is running on localhost 8080. Let's open the browser. If you navigate to localhost 5173, you will navigate to the login page. User can also register and we can provide the name, email, password and confirm password. If the user did not enter the necessary details, then we will show the validation error messages. Let's go ahead and enter the details. Name, I'm going to provide my name. The email address bhushan@example.com. In case if the user did not provide the correct email, the valid email, it is going to show a different validation message. Email is not valid. Make sure to provide the valid email address. Next, we're going to provide the password. If the user did not provide the confirm password correctly, then it is going to show a different validation message. Password must match. Now, when they click on this register, we will show the message profile is successfully created. Of course, we can improve this. We can show the alert messages instead of just showing the text. Like I said before, still it is in development stage. We are going to improve this further. Let's go ahead and create one more user. Bharat SC, Bharat at example.com, password 123456, 123456. Click on this register. You can see profile is successfully created. Now go to the login and login for Bhushan. And if I provide a wrong credential, then we will show the bad credentials error message. Let's enter the valid credentials and click on this login. Now we navigate to the dashboard page. This is the dashboard and we have the new expense and new and reports. Inside the dashboard, we are going to show the list of expenses that the user is created, and we are going to show the welcome message, welcome and logged in user email address, and also we are going to show the total expenses, and we will show the today's date. Of course, this Bhushan at example.com is currently hard coded. Later we are going to add based on the logged in user email address. Let's go ahead and create a new expense. Click on this new expense. Again, this form is also added the validation. So if the user is trying to click on this save, we get the validation error messages. Let's provide the necessary details, water bill and amount 789. We can provide the note, some note, and by default we are going to set the date as today's date. You can also change it, and we can select the category, suppose utilities, and click save. A new expense is created. Let's go ahead and create one more expense. Mobile phone, say 8,000, and iPhone, and we can provide the shopping as a category and click save. A new expense is created, and you can see the total amount you can see in the top. And now user can also see the complete details of the expense. Click any one of this expense. It is going to take us to the expense details page. We can show the expense details in a table format, and we have a couple of action items: back, edit and delete. Click on this back. User will navigate back to the dashboard, and also click on this edit. User can edit the expense, updated expense, click save. You can see updated expense, and also user can delete the expense. Click on this delete. It will show us the confirmation dialog box. Confirm. It is going to delete the expense. Also, we have this reports. Later we are going to generate the reports for the expenses. Click on this logout. User can logged out, and now let's log into a different account. Bharat at example.com, 123456. Click login, and you can see Bharat did not create any expenses and he cannot able to see other expenses. Let's go ahead and create a new expense. Also, you can see this is hard coded like I said before. Later we are going to change it based on the logged in user email address. Let's create electricity bill and amount $1,000 bills, and we can select the date, and also utilities is the category. Click save, and you can see this is the Bharat's expense, and this is only Bharat can see his expenses. Now let's log out, and now if the user is trying to navigate to the any of the routes without logging in, and he will navigate back to the login page. Let's say suppose reports, and he cannot able to see those routes. Similarly, new expense, he cannot able to see those expenses or the routes until unless the user is logged in. Similarly, if once the user is logged in, he cannot able to navigate to the login page and register page. If I try to hit the login, then we are navigating back to the dashboard. Similarly, for the register also, we are navigating back to the dashboard page. Also, the entire application is completely mobile responsive. You can see the items, dashboard, new expense, reports, and if you go to the new expense, the entire form is mobile responsive. You can see, and also if the user try to delete the expense in the mobile view also, it works as expected. Alright, this is the application that we are going to create as a part of the course. Don't think this is a very small application. The learning curve is so much, we are going to learn so many things while creating this application. And this is not the end of the development. I'm going to add so many features to this application. I'm planning to scale this application as much as possible. I have planned to add more features like filtering the expenses based on the dates and keyword. Also, we're going to sort the expenses and we're going to add the pagination. We will add the category module so that each user create his own category and he can add the expenses based on the category. Also, we can provide a different login methods like login by Google, login by Facebook, and login by maybe LinkedIn. We can provide a different login methods. Also, we're going to create and integrate the email feature. When the user register to the application, we're going to send an email to the inbox and we're going to authenticate the user email address. Also, we are going to add the reports. Like I said before, user can generate the reports and he can also set a reminders for every category, and once the certain amount is crossed for the category, we are going to send an email notification you have crossed the threshold. Also, we can add the income module to the application. The expense module currently we have added. Similarly, we can add the income module so that the user can also add the incomes. And also have planned to upload the bills to the AWS, and then we are going to see those bills inside the dashboard. These are the plans that I have planned for this course. In case if you want to know how we can create all these features in React and Spring Boot and how we can scale this application, come and join this exciting journey so that we can learn together and we can grow together professionally. That's all from my end. See you inside the class. In this video, let's create a Spring Boot starter project. Let's look at the development steps to create the Spring Boot starter project. We will create the Spring Boot starter project using Spring Initializer. Spring Initializer is an online web tool created by Spring team. The Spring team specifically created this online web tool to create the Spring Boot starter projects quickly and easily. On this web tool, we will provide the necessary informations like the project type, the programming languages we are choosing to create the Spring Boot application, and the Spring Boot version, and the project metadata details such as group ID, artifact ID, name of the application, the description, package name, and how we are going to package the application. We will provide the Java version, and also we will add the dependencies. Basically, on this web tool, we will provide all the necessary details to create the Spring Boot project, and the Spring Initializer will take care of everything. It will configure everything and it will give us the project structure. All we need to do is we just need to generate this project. It is going to download the zip file. We need to extract that zip file and we need to open it in our IDE to start the development. Now let's go to the start.spring.io and let's create the Spring Boot starter project. I open the browser, navigate to start.spring.io. Let's select the project type, which is Maven, the language Java, the Spring Boot version. At the time of this recording, the latest and stable version is 3.3.1. Let's add the project metadata, group ID in.Bhushan Sirigur, artifact ID, REST API, description, Spring Boot REST API, package name, you can leave as it is. This is the default package name. Packaging jar, the Java version. I select Java 17. Now let's add the dependencies. For now, let's add the single dependency, which is web dependency. You can read the description about this dependency, build web, including RESTful applications using Spring MVC. Let's select this dependency. And before creating the project, you can also see the files and folders. Click on this Explore and you can see the files and folders. Select the pom.xml. If you scroll down, you will notice the dependency which we have added, Spring Boot Starter Web dependency. The Spring Initializer also add one more dependency by default, which is the Spring Boot Starter Test dependency, which is for writing the unit test cases. Later we can remove this dependency. For now, go ahead and click on this download. This is going to download the zip file. Go ahead and extract this zip file and open it in the IntelliJ IDEA. I opened the project inside the IntelliJ IDEA. If you are opening the project very first time, it will take a couple of minutes to download all the dependencies. Once it downloaded all the dependencies, you will see this green check mark, which is synchronization and test passed. This is the typical Spring Boot project structure. We will discuss about these project structure in the next video. In this video, let's understand the Spring Boot project structure. We just now created the Spring Boot starter project. Let's understand the project structure. This is the typical Spring Boot project structure when we create using Spring Initializer. Now let's understand each file and folder, what it does. The first directory is the root directory. The folder, the project folder itself is the root directory. Inside this directory, it contains the essential configuration files and folders for our project. Under this root directory, there is a file called pom.xml. This is the build configuration file. If you are using a Maven, then pom.xml is the build configuration file. Inside this file, we will add the dependencies, plugins, and other build instructions. All the project dependencies will be present under this XML file. Next is the source directory. It contains the source code and resources for the application. Inside this, we have two things, source main and source test. Under the source main, we have the Java folder as well as the resources folder. The Java folder, which is nothing but the main source directory for the Java code. We will add all our Java classes inside this folder. Under this, we have a default package, which is in.bhushan-sirgur. This is the base package for all of our application classes. We will create sub packages under this package. This will be the base package. Inside this, we have a class, the Java class called REST API application.java. This is the main application class, which is annotated with Spring Boot application. This is the entry point to our application. It contains the Java main method. Next, we have the resources folder. The resources folder, which contains the application resources. Under this, we have the application.properties file. You can also add the application.yaml file. By default, it will add the application.properties file. It contains the configuration files for the application. Inside this, we will define how our application will run, and related to our application configurations, we will add it here. For example, the server port and the data source configurations and a few other configurations, we will add it inside this property file. Next, we have the static folder, templates folder, and public folder. If we are creating the REST API application, then we don't need these folders. If you are creating a web application, if you are using the server-side templates, then we might need these folders. Inside the templates folder, we will add the server-side templates such as Thymeleaf or FreeMaker templates. And we will add the HTML, CSS, JavaScript file under the static folder. Under the public folder, we will add the alternative location for the static resources. If you are creating the JSP, then we will add it inside the public folder. Next is source test. Just like source main, we have a source test. Under the source test, we have a Java folder. Inside the Java folder, it contains the unit test classes. If you are writing any Java unit test classes, then we will be present inside the source test Java. Under this also, we have a default package, which is in.bhushan-sirgur. This is the base package for the unit test classes. Under this, there is a default test class which is REST API application tests, and this will added the annotation Spring Boot test annotation. This is going to load the full application context for the integration test. In this course, we are not going to touch the unit test cases, so we don't have to worry about this source test folder at all. Next is the additional files. We have the git ignore, mvnw, mvnw.command, and readme.md. The git ignore is for the git. It is going to tell which all the files we have to ignore while committing it to the git. Next, we have the mvnw and mvnw.command. mvnw is for shell script running the Maven wrapper on Unix based systems. If you are running the Maven application on Unix based system, this file will be helpful. Similarly, mvnw.command is batch script for running the Maven wrapper on Windows systems. If you are running the Maven project on Windows systems, then this file will be helpful. Similarly, we have the readme.md. It is a markdown file with information about the project, how we are going to run the project and what are the configurations that are required. All we can define it in this markdown file. This is about the project structure. In this video, let's create the React starter project. Let's look at the development steps to create the React starter project. Open the terminal. If you are using the Mac, open the terminal. If you are using the Windows, then open the command prompt. We are going to create the React starter project using Vite. In order to create the Vite project, execute the command npm create followed by the keyword Vite. This is going to create the Vite project. We need to provide few other informations while creating the project. First, the Vite will ask you to enter the project name. Enter the project name, for example, web app. Next, Vite will ask you to select the framework. Using Vite, we can create project with a variety of frameworks. We can create the Vue project, we can create the React project, we can create the Svelte project, we can create the Solid project, bunch of other options available. In this course, we will be creating the React project. So let's choose the framework React. Next, it will ask you to choose the variant, whether you are using the TypeScript or the JavaScript. In this course, we will be using TypeScript. Let's select the TypeScript. Next, it will create the project, and it just created the project, but it did not install the dependencies. Now we have to navigate to the project and we have to install all the dependencies. Like I said before, it did not install the dependencies. It just configured the dependencies inside the package.json file. Now we have to navigate to the project folder and we have to install all the dependencies and we can start the development server. Let's navigate to the project folder and install the dependencies using the command npm install. This is going to install all the necessary dependencies that are specified in the package.json file. Once it installs all the dependencies, we can start the development server using the command npm run dev. This is going to start the development server on the port localhost 5173. Let's go ahead and create the React starter project and let's start the development server. I have opened the terminal. Let's execute the command npm create Vite and hit enter. It will ask you to enter the project name. Enter the project name, web app. Next, select the framework. Using the down arrow key and up arrow key, you can select the framework. Let's select React and we need to select the variant. Let's select TypeScript and it created the project. Now we need to navigate inside this project and we need to install the dependencies. Let's do it. I'm going to clear the screen, navigate to the project folder, web app. Next, install the dependencies, npm install or npm I for short. Hit enter. It is going to install all the dependencies. This will take a couple of minutes depending upon your internet speed. It installed all the dependencies. Now let's start the development server. In order to start the development server, npm run dev. This is going to start the development server on the port localhost 5173. We can verify this. Let's go to the browser and navigate to localhost 5173. Hit enter. You will see the application is running on the port localhost 5173. In the next video, let's understand the project structure. In this video, let's understand the React project structure. We just now created the React project using Vite. Now let's understand the project structure. This is the typical React project structure when we create using Vite. Now let's understand each file and folder, what it does. The first is the root directory itself. The project folder itself is the root directory. This root directory contains the essential configuration files and directories for our project. Next is the node modules. This is the directory where it contains all the npm dependencies that are required for our project. Our project depends on a lot of the libraries, and this node modules contains all those dependencies. If you remember, while creating the project, the Vite has installed the dependencies, and these dependencies will be present in the package.json file. And now when we install those dependencies, the node modules will be created. Under this node modules, all the dependencies will be present. It is managed by npm. Next is public folder. This public directory is where we put all our static assets like images, fonts, and other files that we wanted to be served to the browser directly without processing the Vite. This is a folder where we can add all those files and folders, the images, static images, fonts, so that the Vite will not process this. It will directly render it into the browser. Next is the source folder. Inside the source folder, we have the assets folder, and this source directory is where we put all of our application source code. This is where we spend most of our development time. Inside this, we have the assets folder. This is where we store all the assets, the static assets that are imported to the Typescript files. Inside this, we will add the logos and other images that are required for our project. We will import these assets inside our Typescript files and we will use it in our project. Next is the app.tsx. Every React application contains a root component. We will talk about the component as we go further in the course, but now let's understand component is the building block for the React application, and every React application contains a root component, which is nothing but the app component. This component contains other components that are rendered to the browser. This is the main component. It contains other components. That's it. Next is the main.tsx. This is the entry point to our React application. It typically contains the code to render the root component. If you remember, we talked about the component which is app.tsx, that is the root component, and this main.tsx contains the root component. The main.tsx will render the app component, and the app component will render other components that are required for our application into the DOM. Next is the index.css. This is the file where we are going to add all our CSS code. This is a global CSS style that are required for application. If you want to add any CSS to our application globally, this is the place you are going to add. Next is the git ignore. You know that the git ignore is for git. If you wanted to ignore any of the files and folders while committing to the git, this is the place where you can add. Next is the index.html file. This is the main HTML file for our application. Unlike any other traditional React apps created using create React app, Vite also uses this as the template HTML file directly. And this is the only HTML file will be available in our React application. This contains a div with the ID, and inside this div, we are going to render the app component, and the app component will render all other components, and that contains the HTML content. Next is the package.json file. This file contains the metadata about our project and list of dependencies and the scripts that how we are going to run the application for the npm. Kind of a pom.xml in our Spring Boot application. It contains all the dependencies and scripts that how we can run the application and other build informations. Next is the tsconfig.json file. This is the configuration file for the TypeScript. It specifies the compiler options required to compile our TypeScript code. This is just a configuration file. We are not going to touch this. Next is the wait.config.js. This is the configuration file for wait. You can customize this behavior of the wait using this file. Next is the readme.md file. This is usually contains the information about our project, how we can run the project, how we can build the project. You can also add instructions how we can run the application inside this readme.md file. Apart from these files, there are few other files also present. Those are the configuration files. We don't have to necessarily understand all those configuration files because that is irrelevant to us. These are the main files and folders that we have discussed so far, and we will be working with these files and folders most of the time. This is about the React project structure. In this video, let's discuss the development steps for fetching the expenses from the database. Here are the development steps. The first step is to create the database. Second, we will configure the data source inside our application. Third step is to add the necessary dependencies to our application. Fourth step is to create the IO objects. Fifth step is to create the data transfer object. Sixth step is to create the JPA entity. The seventh step is to create the JPA repository. And the eighth step is to create the service. Ninth step is to create the controller to define the endpoint. And the last and final step is to test the API. Now let's discuss these steps one by one in detail. The first step is to create the database. We need to create the database inside the MySQL server. For that, open the MySQL workbench and execute the following query. The query is create database followed by the database name. Expense transactions is the name of the database. Once you execute this query inside the MySQL workbench, it is going to create a new database inside the MySQL server. The next step is to configure the MySQL database. We need to add few properties that are related to the MySQL into our application.property file. Open the my application.property file, add the following properties. The first property we are going to add is the data source URL. We need to provide the JDBC URL. In this case, JDBC:/mysql:/localhost:30:306, which is the port where our MySQL server is running. And expense transactions is the name of the database. The next property we are going to add is the database username. In my case, it's root. Next, we will add the MySQL password. Also, we will add few more properties that are related to JPA. The first property is DDL-auto. We are going to set this to update. Instead of we executing the queries to create the tables, we tell JPA to create the tables for us. Based on the entity configuration, the JPA will create the tables for us. And for that, we have added this property DDL-auto. We will set this to update. Few other options also there for DDL-auto, but we will add update to this property. Next, we will add the show SQL to true. Whenever the JPA executes query, it will print in the console. For that, we have added the show SQL to true. And the last property we have added is the servlet context path. This is not related to data source or any sort of the configurations. We just added for the application purpose. Context path, once we added this value /API/v1, all our API endpoints will be prepended with /API/v1. This is just the context path to our API. The next step is to add the necessary dependency to our application. We need to add the following dependencies into our pom.xml file. Open the pom.xml file, add these dependencies. The first dependency that we're going to add is the Spring Boot Starter Web dependency. Using this dependency, we can create the web application. We can also create the RESTful web services. The next dependency is the Lombok dependency. This is a Java library. It will help us to reduce the boilerplate code. We can use the annotations which is provided by the Lombok. Using these annotations, we can reduce all of the boilerplate code. In the following lectures, let's understand what kind of annotations it will provide and what kind of boilerplate code it will reduce us. Let's add this Lombok dependency into our pom.xml. The next dependency is the Spring Boot Starter Data JPA. This is the JPA dependency. Using this dependency, we can interact with the databases. We don't have to write SQL queries. Instead, we can use the Java objects to interact with the database. It provides the ORM framework, object relational mapping. It will help us to save the Java objects into the database. It will provide a handful methods to interact with the databases. We will learn more about the JPA as we go further in the course. The next dependency is the MySQL connector dependency. This will help us to connect to the MySQL database. And the last dependency is the model mapper. In our application, we will create a bunch of Java objects. For example, the IO objects, DTO objects, and entity objects. While interacting these objects, while communicating these objects from one object to the another object, we want to copy the values. Instead of copying the values manually, we can use this model mapper to copy the values from one object to another object. You will understand how it will helpful while writing the code. Just add the model mapper dependency. The next step is to create the IO object. As I said before, in our application, we are going to create the IO objects. These IO objects are nothing but the request and response objects. These objects contain the private fields, setters, and getters. This is just a Pojo class. It will contain the private fields, setters, and getters. These IO objects mostly interact with the presentation layer. You know that our application is divided into multiple layers: the presentation layer, and the service layer, and the database layer. And these IO objects will mostly interact with the presentation layer, and it will never interact with the database layer or the service layer. The React application will send the JSON data, and we will bind those values to these request objects. Similarly, the response object will be converted to JSON data and send it to the React application as a response. This is just the request and response objects. The next step is to create the request object to hold the expense data. We will create the expense request Java class, and inside this we will add the fields name, note, category, date, and amount. This expense request will define the expense object, and we will add the annotations. The data annotation is from the Lombok. As I said before, the Lombok is a Java library. Using this annotation, we don't have to generate the setters, getters, toString, equals, and hashcode method. Just by adding this data annotation, automatically Lombok will generate the setters, getters, toString, equals, and hashcode method for us. And all-args constructor annotation, it is nothing but the constructor for all of the fields. And no-args constructor, the name itself says that it is a no-argument constructor. And the builder annotation, if you want to use the builder design pattern on this, we can use it. This is also from the Lombok. The next step is to create the response object to send the response back to the UI application. Just like the request object, we will also create the response object, and we will add the Lombok annotations, data, all-args constructor, no-args constructor, builder annotation, and we will also define the fields like expense ID, name, note, category, date, amount, created that, updated that. Just the Java Pojo class which is used to hold the data. The next step is to create the DTO object for expense. DTO stands for data transfer object. It is a design pattern. It is widely used in the industry. These objects similar to IO objects, but these objects will interact with the different layers of the application. Sometimes these data transfer objects will interact with the presentation layer and the service layer, even though sometimes it will interact with the database layer as well. And these are the objects that will travel from one layer to the another layer. These objects contain the private fields, setters, getters, toString, and hashcode methods. These objects sometimes contains the sensitive data of our application such as passwords and other sensitive data. And these objects will never return as a response to the UI application. Unlike the request and response objects, this will not send it back to the UI application. This purely interact with the service layer, presentation layer, and the database layer. But these objects will never send it back to the React application or the any UI application. The next step is to create the DTO object for the expense. We will create the expense DTO Java class and we will define the fields, expense ID, name, note, category, date, amount, created at, updated at. And also we'll add the Lombok annotations, which is data annotation, all args constructor, no args constructor, and builder annotation. The next step is to create the JPA entity for expense. These JPA entities represents the database objects. And these JPA entities helps us to represent the structure of the table. If you are defining the JPA entity, which means that we are defining the structure of the table through the Java class. Unlike other DTO and IO objects, these entity objects also contains the private fields, setters, getters, toString, hashcode, equals method. The entity class is mapped to a database table. Basically, if you are adding the annotations, the JPA annotations for the class, which means that the entity class is mapped to a database table. And every field is mapped to a column inside the table. The fields what we define inside the entity class, that will be mapped to a column inside the table. And these mapping will be done through the help of the JPA annotations. The JPA will provide a bunch of handful annotations. Those annotations will be helpful to mapping between the table and the database objects. The next step is to create the JPA entity for expense. We have a bunch of annotations. Let's discuss these annotations one by one. The first annotation is the entity annotation. This entity annotation specifies that the class is a JPA entity and it is mapped to a database table. As I said before, this is the annotation that is provided by JPA. If you are adding this entity annotation, which means that the class is mapped to a database table and it is represents the JPA entity. The next annotation is the table annotation. Once we map the Java class to a database table, we have to specify what is a table name. How we are going to map? Through the table name. And using the table annotation, we can specify the name of the table. The expense entity class is mapped to a table, which is tbl underscore expenses. With the help of the table annotation, we are going to map it. Next, all the annotations, you know that data annotation, all args constructor, no args constructor, builder annotation, you already aware of it. The next annotation is the ID annotation. The ID annotation specifies that the primary key for the entity. In table, every table we have the primary key column, and we have to specify in the Java class which field is the primary key field, and we are going to do it through the ID annotation. Here in our class, the ID field is the primary key column, and this primary key column is mapped to a field ID. And also we will specify the generation strategy, how we are going to generate the value for the ID column. We are going to add the generated value annotation. It provides a bunch of generation strategies. We are going to use one of the generation type, which is identity. The next annotation is the column annotation. Inside the table, we have a columns. Similarly, inside the class, we have a fields, and every field is mapped to a column. We are going to do the mapping for the fields and columns with the help of the column annotation. We can also specify the column attributes. Here we are specifying the unique is equal to true, which means that the column should be unique. All the values, the expense ID values should be unique inside the column. The next annotation is the creation timestamp and update timestamp. These annotations purely for the auditing purpose. I want to generate the date and time when the object is created. Similarly, I want to generate the date and time when the object is updated. The creation timestamp will generate the date and time when a new object is created. Similarly, the update timestamp will add the date and time when an object is updated. This is about the JPA entity. The next step is to create the JPA repository for expense resource. Once we create the JPA entity, we need to create the JPA repository. This JPA repository is an interface that extends the either JPA repository or CRUD repository interface. Basically, JPA repository and CRUD repository are the interfaces. If we are creating the JPA repository, we have to extend either one of these interfaces. If we extend these interfaces, then it provides a bunch of handful methods to perform the CRUD operations. Not only CRUD operations, we can also create a custom methods or query methods, which we are going to talk about in the further videos. But basically, these interfaces provides a standard CRUD operations methods. Using that, we can perform the database operations. Like I said before, it also provides the additional methods for pagination and sorting. If you are implementing the pagination and sorting, we don't have to write the logic from the scratch. It will also provide these additional methods for pagination and sorting. We can use that. And the next step is to create this JPA repository for the expense resource. In order to create the repository, we just need to create an interface with the name expense repository. And like I said before, we need to extend the repository with one of the interfaces, JPA repository or CRUD repository. Here we are extending with the JPA repository. While extending with the JPA repository, we need to provide the type which we are going to create the repository. Here in our case, the entity name is expense entity, and we need to provide the primary key type. In our case, in expense entity, the primary key type is long. And if you look at this, this is just an interface, and who is going to do the implementation for this? The Spring JPA will create the implementation class for this. The default implementation class for JPA repository is simple JPA repository. If you look at this, it is going to implement the JPA repository implementation. And by default, this simple JPA repository added the annotation repository annotation. Repository annotation is a stereotype annotation. Whenever the Spring Boot application is started, automatically the Spring will create an bean for this class, and it is going to manage the lifecycle of this class. We don't have to manage the lifecycle of this class. Spring Boot, it will automatically takes care of the bean lifecycle. That is about the repository annotation. In that way, we don't have to add the repository annotation in our interface. We can just skip that because the default implementation is simple JPA repository. If you go inside the simple JPA repository, you can see that it also implements the JPA repository. The next step is to create a service class for the expense module. Services are at the heart of any application. If you're creating an enterprise application, every enterprise application should contain the service classes. Most of the business logic goes inside the service class. We will be writing the heavy lifting code inside the services class, and services will interact with the database layer to perform the database operations. Most of the times the services class will interact with the database layer to perform the database operations. Even sometimes the services layer will interact with the third-party services to get the data. We define the service interface, and then we extend this interface with different implementations. The next step is to create the service interface for the expense module. We create a Java interface expense service, and we define the method get all expenses. This method is going to return the list of expense DTO. And next we are going to provide the implementation for this method. The next step is to create the implementation class for the service. We will create an implementation class expense service implementation, and we're going to implement the interface which is expense service. We add the annotation service, and we're going to add the request args constructor for the dependency injection, and we will add the SL4J annotation for logging purpose. The service annotation is the stereotype annotation. Spring Container will create a bean out of it, and it is going to manage the lifecycle of this expense service implementation bean. We will be injecting the dependencies, the expense repository, and the model mapper. We need model mapper to copy from one object to the another object. We copy from one value to the another value, the objects. That is why we have injected the model mapper as well. Next, we are going to override the method get all expenses. Inside this method, we are going to call the repository method, which is expense repository.findAll. The find all method is provided by JPA repository. This is going to perform the database operation behind the scenes. It is going to fetch all the records from the database and it is going to give us. It is going to write the select query, which is select star from TVL underscore expenses. That is the table name. It is going to fetch all the values from the table and it is going to give us, and it is going to map it to the expense entity object. Next, we will be adding the logger just to see that whether we are getting the values or not. Next, once we get the list of expense entity, we will be converting that into a data transfer object, because expense entity objects should never be sent it back to the presentation layer. We have to convert those into a data transfer objects, because the data transfer objects are the one it is going to send it back to the presentation layer. We will be converting these objects using the stream API, stream.map. We're going to use the map method. The map method will convert from one object to the another object. We are calling the method map to expense DTO, and for that we are going to pass the expense entity. The map to expense DTO will be converting values from one object to the another object. Inside the method, we will be calling the model mapper object, model mapper.map. It is going to convert the expense entity values to the expense DTO object, and it will give us the expense DTO back. And we are going to return the list back to the controller layer. The next step is to create a REST controller for the expense resource. We will use the REST controller annotation provided by Spring Boot. The REST controller annotation will makes the class as a REST controller. It is a combination of controller annotation and the response body annotation. Spring will create the bean out of it, and it is going to manage the lifecycle of the bean. The REST controller annotation is a stereotype annotation. The methods which are present inside this controller class are called as handler methods. These handler methods map to a URI paths using the request mapping annotation with a HTTP methods. All the methods which we are going to define inside this controller will be called it as handler methods, and these handler methods are mapped to a URI paths. And these URI paths we are going to define using the request mapping annotations, and these request mapping annotation will also contains the HTTP methods. The next step is to create the controller class for the expense resource. We are going to create a class with the name expense controller. We will add the annotation REST controller, request R constructor, SL4J, all these annotations we are going to add. The get mapping is internally uses the request mapping annotation. The get mapping annotation is a shorthand for the request mapping annotation with the HTTP get method. If you are using the post method, then you can make it as a post mapping. Similarly, we have a put mapping, delete mapping, and patch mapping. And at the class, we are going to inject the expense service and the model mapper. Again, we need a model mapper to convert this DTO objects to the response object. Inside the get expenses method, we are going to add the logger, and next we are going to call the service method, which is get all expenses. It is going to give us the list of expense DTO. And again, we will add the loggers to print the values from the service. And finally, we are going to convert the expense DTO to the response objects using the lambdas. We will make use of the stream API, and we're going to call the map function. The map function is an intermediate function. Inside that, we're going to convert from one object to the another object. We're going to call a private method which is mapped to expense response, and to this we're going to pass the expense DTO object. And inside this, we're going to make use of the model mapper to call the map method, and the map method will convert from one object to the another object. We're going to convert the expense DTO values to the expense response object, and we're going to return the expense response, and finally we will return the response back to the UI application. And finally, we can test the API. We can test the API inside the browser itself. We don't need any of the REST clients because this is a HTTP get method. Inside the browser, we can enter the URL localhost 8080. It is where our port is running. Our application is running on the port /API/v1/expenses. When we hit this, we will get the data. Of course, in order to work this, we should be inserting some records into the database. I have inserted 2 records into the database. That is why I can able to see these 2 records inside the browser. Alright, these are the development steps, and we are going to do these steps one by one. In this video, let's create a controller. Expand the source folder, and inside the source folder, expand the main folder, and inside the Java folder, we have the default package. Inside this, let's create a new package. I will call this controller. Inside this controller package, let's create a new Java class. We can call this expense controller. I'm going to add this to the Git. Let's expand this. Let's add the controller annotation, REST controller. Inside this, let's create a method, public. This is going to return string. Let's call this get expenses. Inside this, just return a string reading the expenses from database. Let's add the annotation get mapping. We can provide the URI, which is /expenses. Let's save this. Now we created the REST controller. Also, we have created the handler method and we have added the get mapping annotation. All we need to do is let's start the application and let's test this API. When we test this API, it should return the string read the expenses from database. Let's go to the main class. Let me expand this as well. Let's click on this play button and click on this run option. It is going to start the Tomcat server on the port 8080. You can see the Tomcat started on the port 8080. Navigate to the browser. Localhost 8080/expenses, and you can see we are able to see the string reading the expenses from the database. Okay, now we created the API endpoint for the expenses. In the following videos, let's try to read the expenses from the database. In this video, let's add the Lombok dependency to our application. Navigate to the browser, open a new tab, and navigate to start.spring.io. Click on this add dependencies and search for Lombok. Click on this explore and copy the dependency. Navigate to the IntelliJ, open the pom.xml. Let me increase the font. Now we need to add this dependency. Let me scroll down. Just after the web dependency, I'm going to add the Lombok dependency. Also, I'm going to remove the Spring Boot starter test dependency. We don't need this. And inside the test folder, just remove the REST API application test class as well. I'm going to delete this and click on this load Maven changes. It is going to download all the dependencies that are required for the Lombok. Okay, now we have added the dependency. In the next video, let's create the IO objects. In this video, let's create the IO objects. Open the Project Explorer. Inside the default package or under the default package, let's create a new package. I'm going to call this IO. Inside the IO package, create a new Java class, expense request. This is for the request object. Similarly, let's create one more class, expense response. This is for the response object. Let me increase the font for both the objects or the classes. Let me expand this. Okay, now let's add the necessary properties or the fields. Private string name, which is nothing but the expense name. Private string description. Private string category. Let me make this note instead of category. Next, private date, which is the expense date. We're going to import it from the java.sql package. Next, private big decimal amount. These are the properties that are required for the expense request. We can add the necessary annotations, the data annotation from the Lombok, all args constructor, no args constructor, and builder annotation. Let's save this. Next, go to the expense response. First of all, let's copy all these fields and paste it inside the expense response. The expense response contains most of these properties. Along with, we are going to add one more property, which is private string expense ID. Let's add the annotations. Just copy this and paste it. We have added the necessary properties for the expense response as well. Along with, we will add another two more properties, which is private timestamp created at and updated at. Private timestamp updated at. Let's save this. Let's continue in the next video. In this video, let's create the data transfer object. Open the project explorer. Create a new package under the base package. Let's call this DTO. Inside this package, create a new Java class. Let's call this expense DTO. I will add this to the Git. I'm going to increase the font. Let's expand this. This expense DTO object also contains the same properties which we have added in the request and response classes. Let's go to the expense response, copy all these properties and paste it inside the expense DTO. We have the expense ID, name, note, category, date, amount, created at, updated at. Let's add the necessary annotations. We can also copy the annotations from the one of our classes. Just copy this and paste it. Okay, we created the expense DTO, added the properties and added the annotations. Let's continue in the following videos. In this video, let's add the necessary dependencies that are required to our application to connect to the MySQL database. Navigate to the browser. Let me close this. And I'm going to remove this Lombok dependency. Click on this add dependencies and search for MySQL. Click on this MySQL driver. We will also add one more dependency, which is the JPA dependency. Search for JPA and select Spring Data JPA and click on this explore. We need to copy the dependencies, the data JPA dependency and the MySQL dependency. Copy these two dependencies. Navigate to the IntelliJ, open the pom.xml, scroll down just after the Lombok dependency, add the two dependencies. One is for data JPA and one is for MySQL connector. Click on this load Maven changes. It is going to load the Maven and it is going to download the necessary dependencies. Okay, let's continue in the following videos. In this video, let's create the database and we will configure the data source inside our Spring Boot application. First, let's open the MySQL workbench, create a new database, create database followed by the database name, expense transactions. Execute the query. It is going to create a new expense transactions database. We can verify this. Just click on this refresh and you can see expense transactions database has been created. Let's open the IntelliJ and open the project explorer and navigate to the application.properties file. Open the resources, and first of all I'm going to remove these templates and static folder. Just delete this. Open the application.properties file. I'm going to get rid of this spring.application.name, or even we can keep this as well. By default the Spring initializer has added this property. Let me expand this. I'm going to add a comment, database configuration. Let's add the data source configuration here. spring.datasource.url. We need to provide the URL, which is the JDBC URL, jdbc:/localhost:3306/ the database name. Let's copy it from the MySQL workbench. Copy this and paste it. Next we need to provide the username and password for the MySQL database. spring.datasource.username. In my case it's root user. spring.datasource.password is equal to the password for MySQL database is this. Feel free to change the username and password as per your installation. Next, let's add the JPA properties. spring.jpa.hibernate.ddl-auto. We're going to set this to update. spring.jpa.show-sql. We're going to set this to true. Also, I will add the context path for our API. server.servlet.context-path is equal to /API/v1. Now all our API endpoints are prepended with this URI path, which is /API/v1. Let's save this. Okay, now we have created the database and also we have configured the data source. Let's continue in the following videos. Let's create the JPA entity for expense object. Let's open the project explorer. Under the base package, create one more package. Let's call this entity. Inside this entity package, create a new Java class. Let's call this expense entity. Let's add this to the Git. I'm going to increase the font. Let me expand this. Now let's go to the expense DTO and copy all the properties, because the expense entity also contains the same properties. Let's copy all of this and paste it inside the expense entity. Along with this, we will also add one more property, which is private long ID. This is for the primary key type. Let's add the necessary annotations, the entity annotations from JPA. Let's add the table annotation. We can provide the table name. Name is equal to tbl_expenses. Next, let's add the Lombok annotations, which is data annotation, all args constructor and no args constructor. Now let's add the JPA annotations for the fields, the ID annotation for the ID field, and we're going to add the generated value annotation. We need to tell how we are going to generate the value for the ID column. Strategy generation type dot identity. expense ID, we will add the column annotation. We have to make this unique. We're going to set the unique to true. Name, note, category, date, and amount. For the created at and updated at, we will add the annotation, creation timestamp, and update timestamp. Next, we also need to add few more annotations to this created at and updated at. Let's add that also. For the creation timestamp, we will add the annotation column. We will provide nullable to false, updatable to false. This is for the creation timestamp. We also need to add one more annotation, which is builder annotation. Let's add the builder annotation as well. Okay, now we created the JPA entity for expense. Let's continue in the following videos. Let's create the JPA repository for expense entity. Open the project explorer. Under the base package, create a new package. Let's call this repository. Inside this package, create a new interface. Let's call this expense repository. This will be an interface. Let's add this to the Git. I'm going to increase the font. Let me expand this. This expense repository extends the JPA repository. We need to provide the JPA entity name, which is expense entity, and we need to provide the primary key type, which is long. That's it. Now we created the repository for the expense entity. Let's continue in the following videos. In this video, let's add the model mapper dependency and configure the bean for model mapper. Navigate to the browser, search for model mapper. Select the first link, which is from modelmapper.org. Click on this get started. Copy the dependency. Navigate to the IntelliJ. Open the pom.xml. Add the dependency just after the MySQL connector dependency. Load the Maven changes. Next, let's go to the main class. Create a new bean. Public model mapper. This is the return type. Let's call this model mapper. This is going to return a new model mapper object. Return new model mapper. Now mark this as bean annotation. The Spring Boot, as soon as we run the application, the Spring Boot will create an object for this model mapper, and it is going to manage the lifecycle of this object. Let's save this. Okay, now we created the bean object for the model mapper, and also we added the dependency. Let's continue in the following videos. In this video, let's create an interface for service. Open the project explorer. Under the base package, create a new package. I'm going to call this service. Under this, create a new interface. I will call this expense service. I'm going to increase the size and I'm going to expand this. Now we need to create the implementation class for this service. Before that, I would like to add a new method inside this expense service. This is going to return a list of expense DTO. Let's import the list from Java util. This is going to return expense DTO. Let's call this get all expenses. Now let's create an implementation class for this expense service. Open the project explorer. Under the service package, create a new package. Let's call this IMPL, which is short for implementation. Inside this implementation package, create a new Java class. Let's call this expense service IMPL. Let's add this to the Git. I'm going to increase the size of this font and I'm going to expand this. We need to implement the expense service. Expense service. And we need to implement the methods. We have a single method which is get all expenses. Let's override this method. Now we need to add the stereotype annotation, which is the service annotation. Along this, I will also add the required args constructor. Inside this, we need to inject few dependencies. The first dependency that we need to inject is the expense repository. Private expense repository. Let's call this expense repository. We need to make this as final. Next, private final. We will also create we are also going to inject the model mapper. Let's call this model mapper. Now we have injected the two dependencies, which is the expense repository and the model mapper. Inside this, let's get rid of this return null. We need to call the repository method. So the first step is to call the repository method, and the second step is to convert the entity object to DTO object, and the last step is to return the list. Let's follow these steps one by one. First step is to call the repository method. In order to call the repository method, we need the expense repository. Let's make use of the expense repository dot find all. This is going to return the list of expense entity. Let's call this list of expense entity. I'm going to call this list. Once we get the list of expense entity, we need to convert this into a DTO object, because if you look at the return type of this method is list of expense DTO, we need to convert this list of expense entity to list of expense DTO. We can make use of the Java 8 stream API, list.stream. On this, we can call the map method. The map method will convert from one object to the another object. On this, we will get a single expense entity object, and now we can call a private method which is map to expense DTO, and we can pass this expense entity to this method. And next we can call the collect method, and we can convert this into a list, collectors.toList. This is going to return the list of expense DTO. I'm going to call this list of expenses, and finally we can return the list of expenses. Now we need to create this private method. Click on this create method. The return type of this method is expense DTO. Inside this method, all we need to do is we need to make use of this model mapper to convert this expense entity to a DTO object. Let's make use of this model mapper dot map, and we need to pass the object from which we are going to convert this expense entity, and we need to convert this into a expense DTO dot class, and this is going to return the expense DTO, and we can directly return this. That's it. Now we have a service method which is get all expenses. This is responsible for fetching the list of expenses from the database. And once we fetch the database records, we are converting that records into a expense DTO object and we are returning it. We are making use of the model mapper to convert the expense entity to the expense DTO. Let's continue in the following videos. In this video, we will call the service method inside our controller. Let's go to the expense controller. I'm going to open the project explorer and open the expense controller. I'm going to increase the size. Let me expand this. First of all, I'm going to add the annotation which is required args constructor so that we can inject the dependency. We're going to inject two dependencies, private final expense service. Let's call this expense service. We will also inject the model mapper, private final model mapper. Let's call this model mapper. Now we don't need this return statement. We don't need to return the string. Instead, we are going to return the list of expense response. Let's import the list from java.util package. Inside this method, first we need to call the service method. We can make use of this expense service dot get all expenses. This is going to return the, first of all, I'm going to write a comment, call the service method, next convert the expense DTO to expense response, and the last option is, and the last step is return the list or return the response. Let's do this one by one. The first step is to call the service method. We can make use of the expense service get all expenses. This is going to return the list of expense DTO. Let's call this list. And the next step is to convert this list into a expense response list. We can make use of the stream API list.stream.map. This map function will convert from one object to another object. We will get the expense DTO object, and we can call a private method which is map to expense response, and we can pass the expense DTO object, and we can call the collect method, and we can convert this into a collectors.toList, and we will get the list of expense response, list of expense response. We can call this list of expenses, or we can call this response. And the last step is to return the response, return response. That's it. Now we have created a control method. Inside this controller method, we are calling the service method which is get all expenses, and this is going to return the list of expense DTO. And we will convert this expense DTO object to the expense response object using a mapper method. Now we need to create this private method. This is going to return the expense response. Inside this, we can make use of the model mapper dot map. We can pass the expense DTO object, and we can convert this expense DTO to expense response. Just return this. Okay, now we have added the method for map to expense response. Inside this method, we are converting the expense DTO to the expense response object. we are copying all the values from expense DTO to the expense response. In the next video, let's test this API. In this video, let's test the API. I'm going to start the server. The application is started, and also you can see the SQL statements. The JPA has executed the statements and it created the table for us. Now the application is started on the port 8080. First, let's navigate to the database and verify the table. Open the MySQL workbench and just refresh this, and you can see we have this table option. Just expand this and you can see inside the database the table has been created, TBL_expenses. Right now this table should be empty. We can verify it. Before that, we can also see the structure of the table. We can write a query, describe TBL_expenses and execute this. You can see the table structure. Let me expand this. You can see we have the ID, amount, category, created at, date, all these 5 fields. And for the expense ID, the key has set as unique, and for the ID field, the key is set as primary key. And in the extra column, we have the auto increment. Okay, with this, now we can test the API. Before that, let's execute the select query. We can verify what is there in the table. The table should be empty. Just verify it. I'm going to execute this. You can see there are no entries in the table. Just for the testing purpose, what I'll do is I'm going to insert few records. I have already done the insert query. I'm inserting 2 entries. You can find this query in the resources section of this video. I'm going to select this and you can click on this. It is going to execute the query. Let me clear this. Now I'm going to execute the select query. You should be able to see 2 records. You can see one is electricity bill and the water bill. Okay, now let's navigate to the browser. Since this is a API, get API, we can test it in the browser itself. Open a new tab and navigate to localhost 8080. If you remember, we have added the context path, which is /API/v1/expenses, and hit enter. You will see the JSON response with the 2 records. One is electricity bill and the water bill. Now our API is working as expected. Let's navigate to the IntelliJ. Just verify one more time. I'm going to stop the server. I'm going to restart the application. The application is started. Navigate to the browser. I'm going to make a request to the API again, and still we are able to see the 2 expenses, the electricity bill and the water bill. Alright, now we have created our very first API endpoint. In the next video, let's add a few Java docs to all these methods. In this video, let's add Java docs to all the methods so far we have created. Adding Java docs will really helpful in your career. I have seen so many developers will not add the Java docs to the methods which they create. It will be very bad, because in the future any of the developers join your team, and if they are trying to read your code, if they did not understand what the method is doing, then it's very difficult for them. You need to add the Java docs so that they will understand what is the purpose of the method and what parameter it is going to accept and what it is going to return. It will really helpful. So try adding the Java docs whenever you are writing any method in your project. Now let's start adding the Java docs. I'm going to stop the server. First of all, I'm going to add a Java docs to the class. In order to add the Java docs, you need to add slash, and you need to provide triple star, and you need to end with slash, which is a backslash, and inside this you can provide the Java docs. This is controller class for expense module, and you can also add author who has written this class. Next, we can add Java docs for the get API method. It will fetch the expenses from database. This method does not accept any parameters, but it will going to return a list, so we can add the return as list. We can also add Java doc for the private method. Mapper method for converting expense DTO object to expense response object. This is going to accept the parameter which is expense DTO, and it is going to return the object expense response. Next, let's go to the service. Let's add the Java doc for the interface. Service interface for expense module. This is written by Bhushan SC. Let's add the Java doc for get all expenses method. It will fetch the expenses from database. It is going to return the list of expense DTO. Let's say this. I'm going to copy the same, go to the service implementation. Let's add the Java doc for the class. Service implementation for expense module. The author is Bhushan SC. I'm going to add the Java doc, which is it will fetch the expenses from database. It is going to return the list. Next, let's add Java doc for this private method. Mapper method to convert expense entity to expense DTO. It is going to return the expense DTO, and it is going to accept the parameter expense entity. Let's save this. Okay, now we have added Java docs to all these methods. We can test this whether the Java docs is working or not. I'm going to call this map to expense DTO method inside the get all expenses method. Map to expense DTO, and now if you hover over on this method, you will see the description, which is mapper method to convert expense entity to expense DTO. You can also see the parameters that it accepts, which is expense entity, and it is going to return the expense DTO object. So this way the Java docs will really helpful whenever you are writing a very big Java code, and if you are calling a private method or any other method, and if someone has written the Java doc, you can easily read while calling that method, you can easily read the description of that method, what it does and what it is going to accept as a parameter and what it is going to return. This way it will really helpful. I hope you will start adding the Java docs whenever you are writing a new Java method. Let's continue in the following videos. In this video, let's add the loggers. It is very important to add the loggers at every interval of time, so that when we send our code to the production, if something goes wrong, we can easily identify what went wrong using the logs. So let's add the logs. First, let's go to the expense controller. In order to add the logs, we're going to make use of the SL4J library. We can make use of the Lombok library for that. For the expense controller class, I'm going to add the annotation slf4j lombok.extern.sl4j. Now when we add this annotation, now we can access to the logs, log.info, log.debug, log.error. We can access those methods. I'm going to add one logger inside the get expenses API. I want to print the log as soon as we hit this API. Log.info, and we can provide the logger message, that is get/expenses API is called. API get/expenses called. Similarly, we can also add one more log, which is once we get the response from the service layer, I can add here log.info, printing the data from service. I can print the list and save this. Next, let's go to the service implementation, and inside the service implementation, once we make a call to the repository layer, we can print the log message. I can also add annotation to the expense service implementation at SL4J, and we can make use of the log.info to print the log message, printing the data from repository. We can print the list. Let's save this. Now we can test the API, and also we can check the logs whether it is printing in the console or not. I'm going to start the application. The application is started. Let's navigate to the browser. I'm going to, first of all, let's go to the IntelliJ and clear the console. Now inside the browser, I'm going to send a request to the API again, hit enter, we get the response. Now let's go to the IntelliJ and we can check the logs. You can see the log message, which is API get/expenses called, and we can see the message printing the data from repository, and also we can see the logs printing the data from service. Okay, now we have added the logs to the API as well. And the last and final step is we need to commit our changes and we have to push it to the repository. Let's do it in the following videos. In this video, we will discuss the development steps for displaying the expenses in HTML table. The first step is to install the necessary dependencies. Second step is to configure the Axios library. Third step is to create an interface for expense object. Fourth step is to create the service. The fifth step is to create a custom hook to fetch the expenses from the backend API. Sixth step is to create a reusable expense list component. Seventh step is to create a dashboard component to render the expense list. And the last and final step is to update the app component to render the dashboard component. Now let's discuss these steps one by one in detail. The first step is to install the necessary dependencies. As a part of this feature, we are going to install a single library, which is the Axios library. Axios is an NPM library specifically designed to make the HTTP request. In order to make the backend API calls, we need a client, the API client, and we are going to install this Axios library. It is an NPM library. It is specifically designed to make the HTTP request. And most importantly, it is a promise-based HTTP client for the browser. In order to install this library, we need to navigate to the root of the project and we need to execute the command npm install Axios. It is going to install this dependency and register it inside the package.json file. The second step is to configure the Axios library. Installing this library alone will not do anything. We have to configure this library. We need to configure the Axios library to make the HTTP request. While configuring, we are going to specify the API base URL and we will export this module so that inside our components we can make use of the client to make the HTTP request. We need to create a API client.ts file under the config folder, and we are going to call a single method which is provided by the Axios library. Under this, we are going to, for the create method, we are going to pass the object and we will provide the base URL. In this case, it's http://localhost:/API/v1. Next time, whenever we are making any API call from our component, this base URL will be prepended to the URI paths. And finally, we're going to export this module. The next step is to create the expense interface. In React, we're going to create interfaces to define the structure of the component, objects, or even the props. Similarly, here we are going to create an interface to define the structure of the expense object. It contains the properties and its types. We can also make properties optional by adding the question mark to the fields. And finally, we can export this interface to use it anywhere else in the application. We create the interface using the keyword interface followed by the interface name. In our case, it's expense. Inside this, we're going to define the properties: ID, which is of type number, expense ID, which is of type string, name, note, amount, date, category. And finally, we're going to export this interface. And the fourth step is to create the service. In React, we will create the services to make the HTTP calls. We will create the service with a file name expense service under the services folder. These services files contains the JavaScript functions to make the backend API calls. In our case, we are going to create a single JavaScript function which is get expenses. Basically, we will create the ES6 function, and inside that we are going to make a API call. We will make use of the API client and we will call the get method, and we are going to pass the URI path which is /expenses. And for this URI, by default, the Axios library will prepend the base URL. And finally, we are going to return it. And also, we will be exporting this function as a named function. And the fifth step is to create a custom hook. In React, custom hooks are just nothing but the JavaScript functions, and all hooks are start with the keyword use. Anywhere if you are seeing the keyword use, then it means that it is a hook. We will be creating this custom hook with the name use expenses under the hooks folder. We will be creating a ES6 function, and inside this we are going to create a few states. Expenses, error, is loading. Expenses is for holding the array of expenses or list of expenses, and error will hold the error message. If our API fails, we are going to set the error message. Is loading is to set the loader. We are going to set the initial value for loader as false, and for the error initial state will be null, and for the expenses initial state will be empty array. Inside this we are going to call the use effect hook. Use effect hook, again it is a hook provided by React, and this will takes two parameters. The first parameter is the callback function, and the second parameter is the dependency array. By default we will pass the empty array because this use effect hook will be executed very first time when the component is loaded. Next time whenever the state changes or the state updates, again this use effect will be rendered. We don't want this use effect to be rendered every time. That is why we are passing the empty array. If you pass empty array, this use effect will be executed only once whenever the component is loaded or the component is rendered. Inside this we are going to set the loader as true, and next we are going to call the service method get expenses, and this get expenses method will return the promise. In order to handle the promise, we are going to call the then method, and inside then method we will get the response, and we are going to set the response.data to the set expenses function, which is the updater function for the state. And if anything goes wrong, we are going to handle the exception. We are going to call the catch method, and we are going to take the error object, and we are going to set the error message to the set errors. Again, set error is the updater function for the error state. And finally we are going to call the finally method. This finally method, irrespective of success call or the failure call, this will be executed. So inside this finally block we are going to set the loader as false. And finally we are going to return the expenses array, error object, and the is loading state. And finally we will export this as a default module. And the sixth step is to create an expense list reusable component. We need to create a reusable component for the displaying the list of expenses. We will be creating this reusable component under the components folder, and we're going to export it as a default component. Inside this expense list, first we are going to define the structure of the props. This expense list component takes the expenses array as a prop. Whoever is consuming this expense list component, it's their responsibility to pass the expense array as a prop to this list component. Next we are going to define the expense list component, and we will be destructuring the props, and inside this we are going to render the HTML table. Inside this we will be just iterating over the list of expenses, and we will be calling the map method, and it will get the single expense object, and we will be accessing the name, amount, date, and we will be returning the table row. And finally we're going to export this expense list as a default component. The next step is to create the dashboard component. The dashboard component we will be creating under the components folder and under the dashboard, and this component is responsible for rendering the expense list component. Inside this we are going to call the custom hook which we have created, use expenses. This hook will be fetch the expenses from the backend API, and it will return the expenses array, error object, and is loading. And inside this dashboard component we will be checking for the is loading error object. If the error object is present, then we are going to display the error message. If the is loading is true, then we are going to show the loader message. And finally we will be rendering the expenses list component. We will be passing the prop expenses, and we will be passed the value as expenses, which is coming from the use expenses array. And finally we will be exporting this as a default component. And the next step is to update the app component. Inside the root component, we are going to render the dashboard component. The dashboard component is responsible for rendering the expense list component. And the last step is to test the development. We will start the development server, and once the development server is started, we will navigate to the URL localhost 5173, and we should be able to see the list of expenses which are coming from the Backend API. These are the development steps. We will be starting these developments step by step. In this video, let's start the development. Let's take a baby steps. First, what I will do is I'm going to create a new component. Inside the source folder, create a new folder. I'm going to call this pages. Inside this folder, we are going to create the variety of pages inside our application. For example, the dashboard and the expense. And also tomorrow, if you are creating any new module, suppose notes, then I can create inside this pages. Inside the pages, let's create a new folder, which is dashboard. Inside the dashboard, let's create a new component. Let's call this dashboard.tsx. Now let's create a React functional component. RAFCE, hit enter. This will create a new functional component with default export. We can remove this import statement. We don't need this. Okay, now we created this dashboard component. Now we can render this inside our app.tsx. Let's go to the app.tsx. What I will do is I'm going to remove all of this code. Let's get rid of this code. And also let's save this. Let's go to the index.css. Let's remove everything and let's save this and go to the app.css. Let's delete everything and save this. Next, let's go to the main.tsx. Let's get rid of this import statement. We don't need this. And next, we have this app component. We are getting this error. Let's fix this in just a bit. Let's go to the dashboard, and okay, now let's go to the app.tsx. Let's create a React functional component, and we can just get rid of this. Inside the app component, let's import the dashboard component. We have imported it. Inside this, let's render the dashboard component. Let's save this. Now let's go to the main.tsx, and okay, we need this actually, the import statement. I have removed it. Let's import it again. App component, we have imported it. And also this index.css, this is a global style sheet. We need this inside this main.tsx as well, so let's keep it. Now let's save this. Now inside the app.css, nothing is there. Let's close this. Inside the index.css, nothing is there. We can close this. And inside the app.tsx, we are rendering the dashboard component. And inside the dashboard, we are just adding a div and we are printing the text dashboard. Now when we run this application inside the web page, we should see this dashboard text. Let's run the application. npm run dev. This will start the development server. Hit enter, and the application is started on the port 5173. Navigate to browser, open a new tab, localhost 5173. You can see now we are able to see the text dashboard. Okay, in this video we created a new component, which is the dashboard component, and also inside the app.tsx we have imported the dashboard and we have rendered it into the browser. Let's continue in the next video. In this video, let's create the expense array with some dummy values. Then we will try to render it into the browser. Let's start. first of all, what I'll do is I'm going to get rid of this dashboard content, or let's keep it for now. Inside the dashboard, let's create an array const. Let's call this expenses. This will be an array. Inside this, let's create the objects. This expense array contains the objects with the properties ID. We can call 1 and the expense name, which is water bill, and amount, let's say $200. Next, date. We can create a date using new date, and we can convert this to toDate string. Let's copy this object and duplicate it multiple times. We can change the things that are required. Instead of the water bill, let's add this electricity bill. Similarly, we can change this to Wi-Fi bill. Also, I can change the ID to 2 and 3. And we can change the amount. Let's say this should be $500 and this should be $700. Okay, now we will try to render this, or we will try to loop through this expenses array, and we will display it in the HTML table. What I'll do is I'm going to get rid of this text dashboard. Inside this, let's create a table, and inside this, let's create the T head, and inside this T head, we should create the T body, and press tab. We will get the T head and T body. Inside the T head, let's create the table row, and we can use table header, which is th, and I wanted to create with 3 columns, so *3 multiply 3. These are the emits shortcuts, so I believe you're already aware of these shortcuts. Now hit tab. You can see the HTML, the Visual Studio Code has generated the HTML content. Now what I'll do is inside this I will add title. Next we can add amount. Next we can add date. This instead of the title, or let's keep it title. And next we have the T body. Inside the T body, what I'll do is I'm going to make use of the variable which is expenses. We can call the map method on this map, and each time when we loop through this expenses, we will get an expense object. Let's call this expense, and now we can return the table row inside this. So tr, inside the tr, which is nothing but the table row, we can provide the table description, and we can bind the data expense dot name. So let's copy this and duplicate it multiple times, and this should be expense dot amount, and the last one is expense dot date. Now also we need to add this key to the table row, which is expense dot id. Otherwise it will, in the console it will start throwing the exception that it is not, the key does not have provided to the unique HTML table row. So with this, now let's save this, and automatically the HTML content has been formatted inside our Visual Studio Code. With this, now we should able to see the expenses in the HTML table. Let's go to the browser. You can see now we are able to see the list of expenses inside this browser, but there is no border for this table. Let's go ahead and add the border. We have this table. Inside this table we can add the attribute border, and we can provide the value 1. Let's save this. Now if you go to the browser, you can see we have a nice border around this table. So what we have done is we just created the HTML table. You already know that, you're already aware of the HTML parts. Inside this, we just loop through the expenses array and we call the map method on the expenses array. The map object will, just like in Java, it is convert from one object to another object. And inside this, what we have done is we have taken the single expense object and we are rendering it inside the table row. We just created the table row, and for the table row, we provided the key. We need to provide the unique key for every row, and we accessed the properties using this expense object. That's it. And now we should able to see the list of expenses inside the browser. In the next video, let's remove the hard-coded data and we will try to read the data from the Backend API. Let's continue in the following videos. In this video, let's create the interface for the expense model. In React, we will create the interfaces. Interfaces will helps us to define the structure of the component or structure of the objects. In this case, we want to define how our expense object look like. For that, let's create the interface. It is kind of a model classes in our Java. Let's open the project explorer. Inside the source folder, create a new folder. Let's call this model. Inside this, create a new file with the name expense.ts. Inside this, let me expand this, and also I'm going to increase the font. Inside this, let's create the interface and export it. Export interface followed by the interface name, which is expense. And inside this, we can define the properties. The first property is ID property, which is of type number. Next, expense ID, which is also type of string. Next, we have the name, which is a type of string. We have the description, not the description, we have a note. Let's call this string. And we have amount. Let's call this number. And we have the date, which is of type string, and category, which is of type string. When defining the interface, we can also tell which all the properties is optional and which all the properties are not optional. Let's make this ID as optional because this ID and expense ID will be generated in the backend. So whenever we are later in the class, when we created the expense form, and if you are not adding the ID and expense ID, the Typescript compiler will start complaining. So for that, let's make these two properties as optional, the ID and expense ID. Let's save this. So now we have created the interface for expense object. This interface defines that how our expense object that looks like. In the following videos, let's use this interface. In this video, let's use this expense interface to define the type for the expense array. Inside the dashboard, let's add the type for this expenses array, which is of the type expense. We can import the expense from the model package, and we can add the expense array as the type, and it will start showing the error. That is because we yet to add two more properties to this objects. One is category and another one is description or the note. Let's add this category. We can make this as utilities, and we can make the note as bills. Let's copy these two properties and paste it for other objects as well, so that it will stop showing the errors. With this, now we don't have any errors. Let's save this, and now let's go to the browser. Still, you will able to see the list of expenses inside the HTML table, but this time what we have done is we have created the expense interface and we have defined the type of this expense array. Let's continue in the following videos. In this video, let's create a reusable component which is expense list. Let's open the project explorer. Inside the source folder, create a new folder specifically for components. These are the reusable components that we will add it inside this folder. Let's create the folder components. Inside this, create a new component which is expense list, and inside this, let me expand this. Let's create the React functional component and export it. Let's get rid of this import statement. Inside this, first what I'll do is I'm going to change the text to list of expenses, and next let's go to the dashboard. Inside the dashboard, what we are going to do is we are going to render the expenses list. Instead of rendering this table and everything, we are going to render the expenses list, and expense list component is responsible for displaying the content. Now what I'll do is I'm going to completely move this logic to the expense list. Let's cut everything. Let's cut this and let's go to the expense list. Inside the expense list, let's add the content, and we can import this expense interface, import this and save this. Now inside the dashboard, let's get rid of this import statement. We don't need this. Now inside this, let's render the expense list component. So import the expense list. Let's render it, return expense list. Let's save this. Now let's go to the browser. We should able to see the same result, but this time we have created a reusable component which is expense list, and we have moved all the logic to the expense list, and the dashboard is responsible for just rendering the expense list, and the expense list is responsible for rendering the HTML content, and our app component is responsible for rendering the dashboard component. The app component never going to render the expense list. The app component responsibility is to render the dashboard component, and the dashboard component is responsible for rendering the expense list. This is nothing but the nested components. In this video, let's move these expenses array to the dashboard component, and we will pass these expenses as a prop to this expense list component. That is because whenever we are creating a reusable component, the main goal of the reusable component is whoever is consuming that component in the near future, they have to provide the data to the components. Here in this case, we have hard coded the expenses list, and that is also inside the expense list component, inside the reusable component. This will not become a reusable component because later if I wanted to use this component anywhere else in the application, these data will be stick to the expense list component itself. We cannot change this data at all. So instead of defining the array inside the expense list component, let's move this to the dashboard component, because the dashboard is the one who is calling the expense list. The dashboard component is the one who is rendering the expense list component. Then it's the responsibility of the dashboard component to pass this data to the expense list component. So let's move this logic to the dashboard component. I'm going to cut this array. Let's cut this array and go to the dashboard, and inside this dashboard, let's add this array. Let's import the expense interface. Let's import this, and now we can pass this expenses to the expense list component as a prop. Let's call this prop name as expenses, and we can pass the value which is expenses. Now we need to accept this prop inside our expense list component. Let's go to the expense list component, and inside this, first of all, what I'll do is I'm going to create an interface. Again, we are going to create interface to define the structure of the component. In this case, let's define the structure of our props. Interface, we can call this props, and inside this we have the expenses props, expenses, which is of type expense array. And now we can accept the prop inside our expense list component. Props, we can destructure this. We can destructure. We have this expenses. Now you can see we don't have any errors. Let's save this. And now if you go to the browser, still you can see the same result. But this time what we have done is we have moved the data to the dashboard component, because the dashboard component is the one who is rendering the expense list component. And it's the responsibility of the dashboard component to pass the data to the expense list component. Now, if I go to the dashboard TSX, and if I wanted to add one more expenses, let's say suppose, let's copy this, or I just cut this. I'm going to create a new div. Inside this, let's call one more expense list, and I can define one more expense array. For example, let's copy this and paste it. We can call this list, and here I can pass this list. Let's save this. You can see we have two tables, but this time all these data will be passing from the dashboard component. I can create a new expense array and I can pass it. Now this becomes actually a reusable component. Whoever is calling this expense list component, whoever is using the expense list component in their component, their job is to just pass this expense list as a prop to this component. Alright, I hope you understand about the meaning of reusable component. Now let's go back to the dashboard component and let's get rid of this. We don't need this. Let's save this. Let's go back to the browser. You can see the one table with the expenses data. So far in our application, we have hard-coded the expense list and we are displaying it in the browser. But this is not what we want. We wanted to make the API call to the Spring Boot application, and we have to fetch the records from the database. Let's start doing it from this video. First of all, what I'll do is I'm going to remove one of this duplicate expense array which we have added in the previous video. Let's get rid of this. And in order to make the API calls to the backend application in React, we can use the browser fetch API, or even we can use the third-party libraries. Let's use the third-party library for our project, which is the Axios library. In this video, let's install the Axios library, which is the npm library, and we will configure it in our React application. Let me save this file, and I'm going to expand this terminal window. I'm going to create a new terminal window, and let me clear this. Let's install the Axios npm install, or I for short, and we can provide the library name, which is Axios. Hit enter. This is going to install the Axios library, and now we can switch back to the terminal window. And now I'm going to minimize this. All we need to do is we need to configure this Axios. Let's open the project explorer. Inside the source folder, let's create a new folder. We can call this config. Inside this, let's create a new Typescript file. I'm going to call this API client, and inside this I'm going to expand this. First of all, we need to import the Axios library. Import Axios from Axios library. Next, we need to configure this. We're going to configure this using the create method, axios.create. And to this create method, we can pass the object, and we're going to specify the few properties. The first property is the base URL. We need to provide the base URL in which this Axios library is going to make a request. In our case, it's http://localhost:8080. This is where our Spring Boot application is running /API/v1. Additionally, you can also pass few more properties. Let's say, suppose we can pass the headers and all those options we can pass. But for now, let's keep it simple. We are just passing the base URL. And I can store that in a variable called const API client. And now we can export this as a default module. Export default API client. Let's save this. Now inside our components, we can make use of this API client to call the HTTP request. Let's continue in the following videos. In this video, let's make a call to the Spring Boot API to fetch the expenses. Where we can make a HTTP call, from which component we can make a call. We can make a HTTP call from the dashboard component because this is the component is rendering the expense list component and it is passing the expenses array to the expense list component. So we should make a API call inside this dashboard component. Okay, now inside the dashboard component, where exactly we can make the API call. We can make use of the use effect hook, which is provided by React, because the use effect hook will be called once as soon as the component is rendered to the browser. So inside that we can make a call to the API so that it is going to call the Spring Boot application and it is going to fetch the expenses. And then we can pass those expenses to the expense list component. Let's start the development. Inside the dashboard component, first let's import the use effect hook. Use effect, we have imported it from the React module, and now this use effect hook takes two parameters. The first parameter is the callback function. Inside this we can make an API call to the backend system. And the second parameter, we need to provide the dependencies array. In this case, this use effect hook does not depend on any of the states. We can just pass the empty array so that this use effect hook will be called only once, and whenever next time if any of these state updates, this use effect will not going to run. That's exactly what we want. Okay, inside this, now we can make a API call. In order to make the API call, we need the API client. Let's import from the config package, and now API client, we are making a HTTP GET request, API client dot get, and we can provide the URI path /expenses because we have already prepended the base URL while configuring our Axios. So we can just provide the URI path, which is /expenses. And this is going to return the promise. In order to handle the promise, we can make use of then. We get the response back and we can log this response to the console.log, and we can access the response, and we can also use catch block to handle the exceptions if there is any exceptions. If the API fails, we need to handle the exception. So for that, we can make use of the catch block. This is going to take the error object and we can log the error object to the console. Alright, now we are making an API call to the backend system with a URI path /expenses. For this URI path, it is going to prepend the base URL, which we have configured in our Axios configuration. And this is going to return the promise, and we are handling using then, and we are also handling the exception using the catch block. With this, now nothing gonna happen. I mean, like the table will not be updated because we are not doing anything. We are just logging the response to the console. But we can verify it whether we are really able to make an API call to the backend system or not. Let's first go to the IntelliJ and whether see we are running the application or not. Okay, the application is not started. Let's start the application. I'm going to start the application. Application is started on the port 8080. Now let's go to the browser. I'm going to open the developer tools and let me clear this, and let's go to the console. I'm going to just reload this, and we should able to see the console logs inside our developer tools console, and we should able to see the response. If you expand this, you will see we have a different objects, the config, data, headers, request, status. The status, if you look at this, it is 200. The API request is successful, which means, and the object which we are interested in is data. If you expand this, you will see the two expenses objects. One is electricity bill and the water bill. We can verify this whether these are the data which are coming from the backend API or not. Let's open a new tab and navigate to localhost 8080/API/v1/expenses. And you can see the same data, which is electricity bill and water bill, which is also coming from our backend API to our React application. Now we can make a request to the backend application inside our React application. Now, once we get this expenses, now we can update the state and we can pass the state to the expense list component. Let's continue in the following videos. In this video, let's create React states to hold the expense data as well as the error data. Let's create those things. Inside the dashboard component, first let's import the use state hook. This is the hook we are going to use to create the React state. This use state hook initially will be contains the empty array. This is for holding the expenses array. This will be initially empty array, and we can specify the type of the data which it is going to hold. We can make use of the expense interface and we can specify it, and this is going to return the array, and we can destructure the array. It is going to give us the two values. The one value, the first object is nothing but the value itself, and the second object is nothing but the updater function. We can call this expenses and set expenses. Next, we will also create a one more state to hold the error object. Use state. This will be initially null. We can call this error set errors. I'm going to create one more state for the loader. Later we can use the loader. Before we are calling the API, we can add the loaders and we can show some loading animations. For now, let's just create the state. Use state. Initially this will be false. We can set this as is loading and set loader. We are getting this error, that is because we have already defined this expenses. Let's get rid of this. We don't need this array anymore. Okay, now we have defined the states. One is for holding the expense array, another one is for holding the error object, another one is for the loader. Now inside the use effect, once we make an API request to the backend system, once we get the success response, inside this we can update the state. Inside the success response, I'm going to update the state using the set expenses. We can make use of the response.data. This will gives us the expense array from the backend API. We are assigning this to the expenses object using the updater function set expenses. Inside the error block, I'm going to do the same thing. Let's make use of this set errors, and we can make use of this error object error.message. We are setting the error. Also, I'm going to call the finally block. This finally block will be run whenever the exception runs. So I can set the loader false inside this finally block. I'm going to set the loader as false inside the success block as well. Set loader. Let's set this to false. Let's save this. Okay, now we are actually making the API call to the backend system. Once we get the success response, we are updating the state, and next we are setting the loader as false. Also, inside the catch block, we are updating the error state as well, and inside the finally block, we are setting the loader as false. Okay, now we can test our implementation whether it is working as expected or not. Let's save this. Let's go to the browser. You can see now we are able to see the two expenses, which is electricity bill and water bill, and these list of expenses are coming from the backend API. Let me remove this. Let me clear this, and I'm going to reload this again. You can see we are getting this warning: each child in a list should have a unique key or a prop. What I'll do is let's go to the Visual Studio Code and let's go to the expenses list. And here this inside the expense list, if you look at this, we have this expense.id. This ID, for some reason it is not working. What I'll do is I'm going to make this as expense ID. Let's save this, and now let me reload this. You can see now we are not able to see those errors. Alright, now we are able to see the list of expenses in the browser. In the following videos, let's handle the exceptions as well. Let's show the exception message if something goes wrong while making the request to the backend system. In this video, let's display the error message inside the browser if our API gets failed. Before that, in the previous video, we encountered one issue, that is in the expense list component. If we try to access the ID, we were getting the error. Let's save this. Let's go to the browser and let me reload this. You can see we are getting this error. We are not able to access this key prop. But are we getting the ID from the API first? Let's check that. Let's go to the network tab and go to this expenses, and inside this response, you can see we are not sending the ID. Actually, we should never send the primary key ID to the response. That is why we created this expense ID. Instead of the ID, we need to use this expense ID. Let's go back to the Visual Studio Code and let's change this to expense ID. Now, inside the browser, we should not able to see those errors. Awesome. This is the first thing. The next thing is, I also missed one more thing, that is inside this dashboard component. Before we making a call, we should set the loader to true, so that we are making the API call, so that we should set the loader as true. I forgot that. Let's do that as well. Set loader. I'm going to set this to true. Now, before calling the API, we are setting the loader as true. After we get the success response, we are setting the loader as false, and in the catch block also we are setting the errors if there is any error occurs, and we are in the finally block we are setting the loader. And this finally block, irrespective of the success response or success scenario or the failure scenario, it will run. In that case, there is no point to set the loader as false inside the success response. We can get rid of this. We can just directly set the set loader as false inside the finally block. Okay, let's save this. And now we need to display the error message if our API gets failed. What I'll do is, let's go to the inside the div, we can check whether the error object is present. If the error is present, then we can display the error message. We can display it in the paragraph tag. We can display the error. Let's save this. Now, in order to simulate this scenario, what I'll do is, let's go to the API client, and I'm going to just remove this I from this API keyword. Let's save this, and now let's go to the browser, and you can see now the API gets failed, but inside this browser you can see network error. You can see this network error. Now we're able to see the error message inside the browser. In the upcoming videos, we will show this error message in a nice alert box, or we can make some CSS to this paragraph. For now, let's keep it as it is, network error. Okay, now let's go back to the Visual Studio Code. I'm going to fix this back. Let's save this, and we can reload this, and you can see now we don't have the error at all. Okay, and the last thing that I would like to address is that if you look at this, we are setting the loader as true before making the API call, and we are setting this false whenever API gets success, as well as whenever the API gets failed. We are stopping the loader. Now I would like to show the loader as well. Whenever I'm making a call, whenever I set this loader as true, I would like to show the message loading. For that, I can again make a use of the is loading. If the is loading is true, then I can set a paragraph that is loading. Let's save this. Now let's go back to the browser. Let me reload this. You might see that little blinking, right? In order to exactly simulate this, let's go to the network tab. I'm going to set the no throttling to slow 3G. With this, now when I reload this, you can see the message loading. Just wait for it. You can see loading, and you can see this expenses list. After once it fetches the records from the database, you will see the expenses. Till the time the loading text you will be seeing. Later in the upcoming videos, we can add a nice animations, the loader and everything. We can improve our application styles. In this video, let's create a service for our React application, and let's move this logic to the service layer. Let's go to the Project Explorer, and inside the source folder, create a new folder. Let's call this services. Inside the service, let's create a new file, the Typescript file, which is expense-service.ts. Let me expand this. Now inside this, let's export a module. Export const, we can call this get expenses. We are just exporting the JavaScript module, and inside this we can make use of the API client. API client, we are importing the API client at top. Dot get, we can call the get method, and we can also specify the type when you make this API call, what data we are getting. We can specify the type of the data that we are receiving. We can make use of the expense interface. Expense, we are expecting the expense array, and we can provide the URI path, which is /expenses, and we can just return this. And now let me save this. Now inside our dashboard component, we don't need this API client and this get/expenses. We can get rid of this, and we can directly import that module, which is get expenses, and we can call this get expenses method directly. Now let's save this, and let's go to the browser. Let me reload this. We should still able to see the same response, but this time we have created the service, expense service, and we have created the module get expenses, and inside the get expenses we are calling the API using the API client, and we are exporting that module, and inside our dashboard component we are importing that module, and we are calling the API. We almost completed our development for the task, but still I would like to see some of the code so that we can refactor it. Inside this dashboard, you can see we are making the API call inside the use effect hook. What we can do is we can move this code to the custom hook, so that in the future, if I wanted to make an API call for this same /expenses API, we can just call the custom hook and we can rate the expenses, because this API is at the core, and /expenses API we might call several times in our application. So that it's better to create a custom hook and we can move this logic to the custom hook. In this video, let's do that. Let's open the project explorer, and inside the source folder, let's create a new folder. I'm going to call this hooks. Inside this hooks folder, let's create a new file. We're going to create a new TypeScript file. Let's call this use expenses.ts. Just like any other React hooks, our custom hooks also start with use keyword. That is why use expenses. Let me expand this. Now what I'll do is I'm going to just create the JavaScript function const use expenses. This is just a regular arrow function. Inside this, what I'll do is let's go to the dashboard component and we can just copy everything. Let's cut this, and inside the use expenses hook, just paste it. We can import the necessary things. Use state we are going to import, also use effect we are going to import, get expenses we are going to import, and what else? The expense interface we are going to import. With this, now we can import this as a default module. Export default use expenses. Let's save this, and we have this expenses error loading. We all need to return this to the caller function. So just return this. Return. We're going to return the expenses. We need this expenses. Also, we're going to return the error and is loading. Let's save this. Now we don't have any warnings in this file, which is great. And let me save this. And I'm going to get rid of this comment. We don't need this. Just save this. Now let's go to the dashboard component, and first of all, we don't need all these import statements. Let's get rid of these. And here inside the dashboard, I'm going to use the use expenses hook. Use expenses. Let's import this, and inside this, let's make use of this use expenses. We don't need to pass any parameters to this hook. It is going to return few properties. We can destructure it. One is expenses, next error, and is loading. All these we need. Let's save this. Now we created the custom hook and we're calling that custom hook. It is going to return few properties back, and we are using it to do some operation. Now let's go back to the browser and let me clear this. Now reload this. You can see we don't have any errors in the console, which is great. And also inside the browser, you can able to see the list of expenses. Awesome. Now we almost completed our development, and the last and final step is we have to review what all the changes we have made, and we have to commit our changes, and we need to push it to the